Next method is substitution suggested by equation. Okay, let's look for the example 1. So the example 1 is x plus 2y minus 1 dx plus 3x plus 2y dy equals to 0. So we let v equals to x plus 2y and dx equals to dv minus 2 dy. Okay, why we need to use this? Because we want to substitute it. So after we let v, we substitute like this. We can put out the x first. X equals to v minus 1. It is actually for this one I have make it simple so it don't look too much. Okay, however, okay, let's look to the example 2 because it is longer and yeah, it's using sine cos. Okay, so the equation is 1 plus 3x sine y dx plus x squared cos y dy equals to 0. Okay, as we want to substitute, so I let w equals to sine y, so dw equals to cos y dy. Okay, so what I need to do is I substitute w into the equation. So I will get 1 plus 3xw dx plus x squared dw equals to 0. Okay, for this one, I want to make it looks to use integrating factor. Okay, first after we get this one, so we use the integrating factor which we need to exponent it. Okay, so after we exponent and integrate the exponential, then we will get x to the power of 3. Okay, so as we know for integrating factor, after we get this one, the output we need to multiply to the equation again. So I multiply x cube to this function and I get this one. Then just integrate and equals to c. So we will get w because we want just let for w only. So like this, we x square minus 2 plus c, we divide by x cube. Okay, so it will looks like this. Since w is something that we substitute, so we change w equals to sine y, so it looks like this. Sine y equals to negative x over 2 plus c. Okay, for the last method is coefficient linear invariance. Okay, for the coefficient linear invariance, for this one, it is like a graph. So for a graph, it has many types. There's a straight line, perpendicular. So for the example 1 is for the straight line equation. For the straight line equation, how we know that it is straight line? Because we get the formula y equals to mx plus c. So for this one, we know the m or the tangent, not tangent, what it called, for the m, I got it is the same, because if I factorize this one, I will get this one. So that is mean it is straight line. Both are straight and parallel to each other. Okay, after that, we let v equals to 2x minus y and differentiate it, and we will get dv equals to 2 dx minus 2 minus dy. Okay, to get because we have dy here, we want to substitute it, right? So we just change the position because we want to substitute dy. It's not dx. Okay, so dy equals to 2dx minus dv. Okay, after that I substitute all. I have make it I put it back into the equation. So like x equals I change this one and I get these terms 3v plus 2 dx minus v minus 1 and 2 dy. Here we change with 2 dx minus dv. So for this is long, I just expand. Okay, after I expand, the final one we will get like this. So for the final this, I want to 1 ds just sit here single, like only ds there. So I bring this one to the other side, so it will become dx equals to negative v minus 1 over v plus 4 dv, and and then I bring it back to the other side, and I will get dx plus v minus 1 over v plus 4 dv equals to 0. So as I have dx and dv, so I integrate, then I get for v minus 1 over v plus 4, I change it because v plus 4 is because this is a fraction, improper fraction. So I need to get I get this one by using long division. Okay, then I get s plus v minus 5 ln v plus 4 equals to c. So for this one, we need to substitute v with the original equation. So I get x and I substitute v to x minus y, and also v here I substitute to x minus y. Then for the final one, this is the answer, 3x minus y minus 5 ln 2x minus y plus 4 equals to 0. That's all from me. Thank you.